Very good morning, everybody. I am Shomabrata Mandal, optometrist, and today I am going to discuss about the topic of retinoscopy. Okay, so I hope those who are in the field of optometry, each and everybody has heard the name of retinoscope, and each of everybody has also seen a picture of retinoscope. So, what is this? Means where is the scope? Where to look from, and where to hold the retinoscope. From the about all this, you will get enough pictures from the book and from the Google or any other videos. Okay, so I will not waste my time on that parts. Okay, so directly in this video we are going to discuss about the procedure of retinoscopy. Okay, but before starting this video, let me clear you that retinoscopy is an art, and the more you practice, the more you will get the correct value of on retinoscopy. But in this video we are going to focus on the crystal clear concept of the retinoscopy, how we do, or rather why we do retinoscopy, and how we get the power. Okay, I will make the concept very clear. Okay, so let us see. So retinoscopy is the procedure what we are doing with the help of instrument retinoscope. Okay, so there are three types of retinoscopy actually. So these are the static, dynamic, and the near retinoscopy. So all these three types can be done with the help of single instrument, that is the retinoscope. Okay, so the static retinoscopy is, the purpose of doing is the to determine or to find out the refractive error or the refractive power of the patient. The dynamic retinoscopy is not any relation with the power. Okay, it is to find out the accommodative lead or accommodative lag of the patient. Means for accommodation lead or lag, I will, or for dynamic retinoscopy there is another video. So in one word, it can I can say that the for a person, according to the age, there is, according to the age and according to the working distance, there is a normal range of accommodation. So if the person is exerting more than that amount, that is the lead, and if it is less, that is the lag of accommodation. I will detail about this in another video. And the near retinoscopy is also a kind of uh, static retinoscopy only, because by means of near retinoscopy also we are determining the refractive error or refractive power of the patient, but it is of a modified way. Okay, so I will explain it in later in very detail. So let's move on. So in this video we are focusing mainly on the concept of the static retinoscopy. Okay, so when you switch on the retinoscope and it focuses on the patient's eye, and you see through the peephole of the retinoscope, first you should understand two words: what is intercept and what is reflex of the retinoscope. Okay, so first, when you enlight the retinoscope light fall on the patient's eye. So there is iris and there is pupil. Okay, so the retinoscope light which is fall on the iris, the in this in this picture, the wide light one, up and down. Okay, so this portion of the retinoscope light which is fall on the iris of the patient, that is called as the intercept. And that portion of the retinoscope light which is inside the pupil, that is called the reflex of retinoscopy. Okay, now the movement of retinoscopy means, if we move the intercept, whether the reflex is moved in the same direction or the reflex is moved in the opposite direction of the intercept, that is the with movement and against movement, or else the neutral movement of the retinoscope. Okay, so here you can see that when the intercept and reflex is in the same direction, this is with, and opposite direction it is against. And practically, let me tell you that in every book, in every PPT, you will find they will tell that in the neutral movement you will get a full glow, the pupil will full of light, but practically it is not like that. Okay, when you end the when you reach the end point of the retinoscopy, or the neutral point of retinoscopy, you will get a like a splitting of the splitting of reflex like this. Okay, actually this is very you will get to it when you practice. Okay, now we are moving on the concept. So, what is far point and its concept on the retinoscope? So, to understand the far point, first you should have an idea on the conjugate point. What is mean by the terminology conjugate point? So, conjugate point means, for example, there are 2 points. Okay, let us imagine 2 points A and B. Okay, so if we put a light source, sorry, if we put a object on the point A, the image will form on the point B, or else if we put the object on the point B, the image will form on the point A. So it has the 2 points. If where we put object, the another point will be the image. So this kind of 2 points is known as the conjugate points. Okay, now the same way, what is its relation to the far point? The relation to the far point is, what is the definition of far point? The definition of the far point is, without any kind of accommodative effort, the maximum distance we can see clearly, that is our far point. Okay, so we can see clearly that distance means if we put an object at that distance, the image will create, or the image will form on the fovea. Okay, so this comes the conjugate point. So that point and our fovea, these are the conjugate points. Okay, so the far point and our fovea, these are the two conjugate points. And why in the concept of far point comes in terms of in the concept of retinoscopy, let us remind the definition of the any refractive error like hypermetropy or myopia. When you read, you probably remember that the parallel rays of light coming from infinity, like this, and at the last of this definition there is one word, one group of words: with accommodation, relax. So when we are doing the retinoscopy, our sole purpose or our sole motto to keep the patient's accommodation very very relaxed. Okay, so relaxing accommodation or without any accommodative effort, the maximum distance patient can see clearly, that is the far point. And that far point should be coincide with the, or should be conjugate with the fovea to get the exact or accurate refractive error of that patient. So that is why the concept of far point is important in retinoscopy. And one more thing, let me tell you that I will explain in later, that when we do the retinoscopy in front of the patient, we will get the with movement, we will get the against movement like this. And that time only we get the neutral movement in retinoscopy, when the patient, when we keep our retinoscope or keep our retinoscope full at the far point of the patient's eye. Okay, so now how the this is one more concept, like how the lens correct the refractive error. So like for example, when a patient comes to you or comes to us and complaining of like I cannot see at distance, so what we do, we put minus lens. So by putting minus lens, what we actually do, we do not we have not are not doing anything to the patient's eye, we are not doing anything to the patient's retina. Okay, so we cannot see at a distance clearly, that means in simple word it's myopia, and the rays, parallel rays of light focus in front of the retina. So by putting minus lens, we are not doing anything to the patient's retina. Okay, so what we are doing, we are actually shifting the focal point of the rays of light from the anterior portion to on the retina. And how we do this, we put the minus lens. So this minus lens actually change the divergence of the parallel light rays. Okay, so what happened now in case of myopic eyes, the the every refractive component is more steep or more curved, so the refractive power of the myopic eye is more than normal. So we need to, rather than to send a parallel rays of light, if we put a divergent rays of light, so what happens, so first to make the divergent rays into the parallel, then it uh, enter the eye and focus on the retina. So see, this is the parallel rays of light, and it is focused in front of the retina. This is a myopic eye, and now what we do, we put a concave lens. It will change the divergence of the parallel light, just make it diverge and let the eyes more refractive power to converge and focus directly on the retina. Okay, so lenses or the corrective lenses alter the vergence of the incoming light rays and correct the refractive error. Okay, so when we change the vergence of the light rays, so and by means what we actually do, when we change the vergence of the light rays, it focus on the retina. So when it focus on the retina, the fovea means the retina means the fovea, so the fovea and the far point are now in conjugates, are get the conjugacy. So that time the patient's refractive error is fully corrected. Okay, now comes to the optics of the static retinoscope. So what we are doing basically in the retinoscopy, we enlight the switch of the retinoscope, shine in the patient's eye. The retinoscope light goes through the pupil, reflects from the retina, and get back to the peephole of the retinoscope. Now, when this retinoscope light reflects from the retina, this will tell the power. This will tell the about the power of the that patient's eye. So this refractive rays has three different characteristics. Okay, so when the patient is hypermetropic, the reflected rays will be the converging rays, and when the patient is myopic, the reflected rays will diverge. So see, in this picture, it is the examiner, okay, and it is a retinoscope. This light go like this in the patients and reflected back to the peephole of the retinoscope. Okay, so in case of if this eye is the hypermetropic eye, what happen, no, this reflected rays will be the converging rays. Okay, and if this is a myopic eye, the this reflected rays from the retina will be the diverging rays. Okay, so now comes to the main fun of the retinoscope, main funda of the retinoscope. Okay, so what happened, this is the patient's eye, and suppose we are doing retinoscopy. Okay, let's imagine, so this ray is going from the retinoscope, and this ray now it is reflected from retina and coming back to the peephole of the retinoscope. Now each and every patient's eye has a different far point. So if the far point is here, that means why, that means what, if the far point is here for this eye, that means what, that means if we put an object here, the patient can see this object clearly without any accommodation, and that is the patient's actual or accurate refractive power. So when we hold this retinoscope exactly at this far point, we will get the neutral movement. Okay, after getting crossing the far point, we will get against motion, and after and before reaching to the far point, we will get the with motion. So in this concept, the working distance, maintaining the working correct working distance during the procedure is very very important. Okay, and also you there are some words is written like slow dull thin, slow dull thin. So it means that when you exactly reach at the neutral point or the neutrality, that means you are on the far point of the patient's eye. So that time the retinoscope reflex means that is on the pupil is very very bright and wide reflex. Otherwise, it will be very dull reflex and thin reflex. But let me again tell you, practically it is very very depends on practice, how you find the how you appreciate the glow of neutrality. Okay. Now, what is the working distance concept? Like many of us doing the retinoscope after putting the plus 1.5 diopter, or many of us doing the retinoscope, we do the retinoscope and then we subtract minus 1.5. So why we are dealing with this working distance? Working distance, what is the concept of it? The concept is that, just remember the definition of the refractive error. So the definition of the refractive error starts with the parallel rays of light. So to determine whether the patient has refractive error or not, or if has how many refractive error he has, we should send the parallel rays of light for accurate determination. So, and parallel rays of light is only possible when we send the light from infinity, but it is not possible for any human to sit at the infinity and to do the retinoscope, isn't it? So what we need to do, when what we usually do, we do the retinoscopy from a finite distance, that is also like one hand distance from the patient. So if we doing the retinoscope not from infinity, then the light which we are trying to obtain the refractive power of the patient's eye, that is also not parallel rays. Okay, so that is actually the diverging rays, because the rays is like the source of the light rays is from near, so that will be the diverging rays. So to make these diverging rays as parallel, we are giving this 1.5 plus 1.5 diopter lens in front of the patient's eye. So what this plus 1.5 diopter lens do, this plus lens will make these diverging rays of light into the parallel rays and then enters into the eye, so that we can get the accurate refractive error of the patient's eye. So that is the concept of working distance. So now for practically how we calculate this working distance, like for usual every we are doing the one hand distance, so one hand distance means 67 centimeter. So the formula is 100 by working distance, or 100 by 67, that is almost plus 1.5 diopter. Okay, so this is the concept of working distance. So it is written that working distance lens makes the retinoscopy as if it were infinity. Okay, you understand? Now the reflex characteristics, this is very very important, okay, for an optometrist. Why? Because when you give or enlight the retinoscope and sends it to the in the patient's eye, the retinoscope light will go and it reflect back from the retina. Okay, so when this retinoscope light reflected back from the retina, it will take so many information, it will take so many texture, so many information about the texture of the patient's eye. Okay, if you get a very bright reflex, if you get a very clear reflex, that means the patient's ocular media, either its cornea or its lens or the vitreous or the retina, everything is normal. So we can proceed with the correction of refractive error for that patient. There is no existing pathology. Okay, so that is the clear reflex. And another type of reflex is the abnormal reflex, means you shown the enlight the retinoscope and send it to the patient's pupil or patient's eye, but you cannot see at all find a glow, that means no glow. Or if shines the retinoscope, but you can see a glow, but that is not that much bright. So what that means, that means that either the patient's cornea or lens or vitreous or any optical media that is obstructing that retinoscope light to reflect back from the retina to the pupil. Okay, so this is the abnormal reflex. So we should not uh, do very accurate refraction in the abnormal reflex. So the retinoscope glow will help you to decide to which patient you should proceed with your refraction procedure, and in which patient you should not waste your time by doing just a refraction. Okay, in the abnormal reflex there are some pathology are present. Okay, so the clear reflex is the three characteristics is there: the speed, brightness, and the thickness. So as I have already explained to you, the more you reach the neutral to the neutrality, the thickness will increase, the brightness will increase, and the speed will increase. The more you far from neutrality, the speed, brightness, and thickness all are decrease. Okay, and in case of abnormal reflex, you have there are six types of abnormal reflex: dull glow, central opacity, regular reflex, ring reflex, no glow, and the varying reflex. So each of in which condition you may get this different types of abnormal reflex, that I will made another video. So for this, up to today, I will end my topic here. Thank you very much for attending my lecture. I think this will be very very helpful for you students. If anything, anybody has any doubt, please feel free to the ask. Please feel free to ask in the comment section of this video. So again, before ending, I will just to remind you, practice makes perfect, retinoscopy and art. Okay, thank you very much.